Hello everyone. So when I did my Q&A video with the Balkan architect, I said this.
BIM is not just REVIT,
Yeah.
of course.
And afterwards I got a lot of messages asking me what exactly I meant by this. So let's talk about it. Okay, so what is REVIT? REVIT is a modeling software. And while of course the BIM model is the most important part of a BIM project, the 3D modeling software is only one of the many tools that you are going to need to deliver and to execute a whole BIM project. You're also going to need tools for collaboration, for quality checking, for the calculations of quantities, of time, for the tendering process. And this is only the planning and the construction phase. If you want to take it to facility management and maintenance, you're going to need a whole new set of software. So today I want to talk not about 3D modeling for a change, but I want to take a look at quality checking. So one big part of quality control is clash detection. So that is essentially if you have different models, for example, one from the architect and one from the MEP team, you load them into the software and sort of fuse them so that the software will be able to detect all clashes that are within the models or between the models. So, for example, if there is a pipe that goes through a wall but there is no opening in the wall, then the software will return an error and show you that there needs to be further planning at this particular point. But with the software that is currently on the market, you can do far more intelligent checks as well. So you can use the software, for example, to check if your toilets meet the accessibility standards of your country, or if all doors have enough clearance in front of them to be able to open. So let's take a look into that. So in my opinion, there are two main software solutions on the market currently for quality checking. One is Navisworks by Autodesk, and the other one is the Solibri Model Checker from the Nemetschek group. And the main difference between the two, I would say, is that Navisworks, you can import all different kinds of 3D data formats. So like a REVIT file, IFC, and usually any kind of format there is, you can import it into Navisworks. While in the Solibri Model Checker, you can only import IFC files. But since Navisworks is a bit more broader tool, and in my opinion, a bit more complicated to use, I want to shed some light today on the Solibri Model Checker. So let's take a look into it. Okay, so this is the interface of the Solibri Model Checker. As you can see, I've already imported this office building into it. And we have here the 3D viewer where we can drag and rotate the building. And then here we can explore the structure of the model. So we can see the floors it consists of. And then if we click on an element, then we can find here all the parameters that are attached to the model. So as we can see, all of the information that was attached to the model got imported as well. And then here on top, you have these different cards that are essentially the steps that you need to go through. So in the first card, after you imported the model, you can do a little visual checking to see if the model was imported nicely and to check the attributes. And then we move on to the checking part. And then here you can decide what kind of rules you want to be checked. And I already did my checking, so we can also see what kind of errors it found, and we have a little summary here of the results. And now if we click on one of the rules, we can see exactly what kind of elements are involved. So for example here, the intersection rule would essentially be the clash detection that I talked about earlier. So two elements that intersect each other. So, and if we take a look at it now, for example here, it found a wall-wall intersection. And if we click on it, it zooms onto exactly the elements that are involved with this. So we can see that here there are two walls that are exactly in the same place. So probably somebody copied it twice and didn't notice, or something like that, and probably would have never noticed it if it wasn't for this checking. But it would have been a problem, because if you, for example, draw the quantities from the model, then this wall would get counted twice, even though it would be built only once. So this would already be something very useful that we've found out about our model, that we didn't found out just with a visual check. And now if we take a look at some other intersection, for example, here we found an intersection between, so there seems to be a problem with walls and columns, that probably somebody just drew one wall, even though there are columns intersecting, so the wall would only be between two columns. But as I said, there are also a bit more interesting rules that you can check with this, apart from just clash detection. So for example, if we take a look here into these rules, and we see here in component check, there's a rule that failed. So the rule checks if all wall dimensions are sensible. So here seems to be a problem with the wall thickness. So let's take a look at it, and we can see that these walls are very, very thick. So probably it would make more sense to make them hollow, so to save on material. Or here it detected walls that are very, very short. So probably they wouldn't be built like that if they're only 5 centimeters long or 10 centimeters. And then something else would be clearance, for example. So to check if there's enough space in front of a window, in this case, to open the window, right? Because of course that would be useful if you're able to do that. So here we can see it has found that here there is a staircase in the way for this window to open. And that happens throughout all of the building. So that would be a real pain in the end if that got built like that. And we can see that this rule is really intelligent, because it didn't only check the floor, but it checked the whole volume of the window. So that is very clever. And then here we have a wall that is too close to a window, and so on. And for especially this, probably we wouldn't even have noticed that this is a real problem with the basin here that is too close to the window. Okay, let's look for some other rules. Oh, so here's accessibility. So what I said before, in this case, it checked for the ramps and found that there is not enough space in front of the ramp. So probably that would be a problem for turning the wheelchair. And same goes for the other one on top of the. So here you can see there would not be enough space for the wheelchair to turn and to go into the building. And the really cool thing about the Solibri Model Checker is that you can also make your own rules as well as modify the existing rules. So for example, if the dimensions for the accessibility are different in your country, then you can modify the rule to fit the dimensions that you need. Or you can make new rules, for example, if you need like a very specific rule for your building, for example, that all walls must have a clearance of 3 meters at all times. So you could also make a rule for that and then use it in the Solibri Model Checker. So if you want me to make a tutorial maybe about how to make your own rules in the Solibri Model Checker, then let me know in the comments. I'd happily do so. But now let's move on to communication. So that is essentially Now we have found all the errors that are in the project, and we want to, of course, communicate them back to the architect or back to the MEP planner. So we can create this little presentation on all the most important issues that we want to be fixed. So for example, here we want somebody to check again on the wall thickness. So we create this issue and we can put a little description for more details. And the advantage of this is that you can export it in the BCF data format, which is just like IFC, an open BIM format. So it can be re-imported by most of the BIM software that is on the market. So when somebody else imports it, the issue will be linked to exactly the same building element. So it will be a little markup and then somebody can see it in his BIM viewer. So it's essentially a very useful communication tool in BIM projects, which allows you to only send these little BCF files and not the whole BIM model, which is of course a much smaller file size. So this is an easy way of how to communicate errors or things that you would like to be changed between the different stakeholders in a BIM project. And you can, for example, also assign a due date to it, or if it's already resolved or not. And yeah, this is already on a very surface level, of course, what you can do with the Solibri Model Checker. Okay, so I hope you like this little overview of the Solibri Model Checker. If you want me to do a more intense tutorial on how to actually use the Solibri Model Checker, please leave a comment down below. Or if you like this form of presenting software and want me to tell you more about other software solutions, I'll be happy to do so as well. So leave a comment down below, and then I'll see you in my next video. Bye bye. Have a nice day.